Good morning, third years. Okay, so we're going to continue on with our number systems topic, and I said that I wanted to talk about a particular type of irrational number, and these are called surds. So surds are a surd, let's give a definition of it, is an irrational number with a square root sign in it. That can't be simplified. To a whole number. Right, let's look at a couple of examples of what those might look like then. So for example, the following are surds. The square root of 2, the square root of 7, the square root of 50. And let's look at what happens when we try and put those into our calculator. So if I type in the square root of 2, and I put it into my calculator like this, the calculator just shows the square root of 2. Okay, it won't simplify it. Okay, if I want to do something, I can change it to a decimal. And remember yesterday our definition of an irrational number was that it was a decimal that went on forever and had no repeating pattern. Of course, we can't see infinity in our calculator, but we can quickly see that there's no pattern being shown here. So this is an irrational number. Same thing with the square root of 7. It's an irrational number. The square root of 50. When I put that in, my calculator will simplify that to 5 times the square root of 2. And just the same way as we wouldn't write 4 over 8 and leave our answer like that, we'd always simplify that to a half. So the same thing with our surds. If they can simplify, we will simplify them. Now I said it can't be simplified to a whole number. So the important thing about surds is that they're irrational numbers. They are irrational numbers. Something that is not a surd, excuse me, would be the square root of 16, or 3 plus the square root of 25. Why? Well, when I put those into my calculator, hopefully you could do these in your head, you can see that that simplifies to a whole number. Okay, so it's not going to be an irrational number. These aren't irrational. 3 plus the square root of 25 simplifies to 8. So these aren't surds, even though they have a square root sign, because they are not irrational. In fact, they're whole numbers. So that's 4, and that simplifies to 8. Okay, some things that are surds that you mightn't expect. So further examples of surds. Would be, for example, the square root of 2 divided by 5. 3 plus the square root of 11. Minus 1, take away the square root of 8. Why? Okay, so they're not just a square root on its own like this. If I put these into my calculator, the square root sign will remain in my answer. So the square root of 2 over 5, it just stays as the square root of 2 over 5. And again, if I press my change button, I can see that I get a decimal that goes on forever and it has no repeating pattern. 3 plus the square root of 11, same thing happening. Minus 1, take away the square root of 8, simplifies it slightly, and we'll be talking about this in a little while. So we would rewrite this in its simplest possible form as -1 minus 2 root 2. So this change here is just the same as when we change 4 over 8 to a half. It's about simplifying it so that we all know that we're looking at the same number. So that's the definition of surds. We have certain laws for surds. So let's look at the 3 laws that we have for surds. The first one says, now these are in our log tables, but they're not always the easiest to read. If I have the square root of 2 numbers multiplied together, then I'm allowed to change that to the square root of each number multiplied like this. It's a little bit hard to read when it's just got A's and B's like that, algebra style, so let's look at an example with some numbers. If I have the square root of 8, I can rewrite that as the square root of 4 multiplied by the square root of 2, because the square root of 8 is the square root of 4 times 2. So I'm allowed to split that square root out like this. Square root of 4 multiplied by the square root of 2. And we just write them next to each other like we do in algebra. You can put in brackets if you want to, but it tends to make it a little bit messier, so we don't need to put in the brackets. Now, we know that the square root of 4 is 2. So therefore the square root of 8 is 2 multiplied by the square root of 2. And that's what we were seeing happening in our calculator. So when we did the square root of 8, the calculator simplifies it to 2 root 2 like that. So if there's ever a part of the number under the square root that has a perfect square in it, we can take it out like this to simplify. We'll be doing further examples with that in a while. So that's the first law. Let's put some words on it. When you have the square root of 2 numbers multiplied, you can split the square root onto each of the numbers. Basically what it's saying is that it doesn't matter if you multiply first and then square root, or if you square root each of them and then multiply. But of course the square root must be on both of them. You can't just square root part of it. The second law of surds is very similar, except it's about division. So if I have the square root of one number divided by another, that's the same as the square root of the number divided by the square root of the other number, like that. So let's look at an example. If I have the square root of 12 over 7, that's the same as the square root of 12 over the square root of 7. And following on from our previous law as well, the square root of 12 can be written as the square root of 4 by the square root of 3 divided by the square root of 7, which doesn't simplify. So our calculator would simplify this to 2 root 3 over the square root of 7. Let's look at that. So I said the square root of 12 over 7. Square root of 12 over 7. And okay, the calculator does something a little bit further as well. We'll talk about this later. It's called rationalizing the denominator. But we'll just ignore what the calculator has with that for the moment. I will show you that if we had 2 times the square root of 3 over the square root of 7, that is the same thing. So for the moment, we'll just leave it like this. There's a task we need to do later called rationalizing the denominator, and we'll come back to that as well. Okay, the third law then. Third law of Surds. It's a really obvious one, actually. The square root of something squared is the number itself. Or it's sometimes written as the square root multiplied by the same thing is the number itself. I apologise, that went off the screen. Okay, so what does that mean? With some numbers, if I have the square root of 3 squared, then that is just 3. Or if I have the square root of 3 multiplied by the square root of 3, that's just 3. Why? Because the square root of 3 squared is the square root of 9, which we know is 3. And by our first law, the square root of 3 by the square root of 3 is the square root of 3 by 3, and that's just 3 as well. Okay, there's another format that this might come in that's useful to note. You can put the square root, the squared sign outside the square root, and that is the same thing as well. So these are 3 ways of writing the same third law. Some words on each of these. For the second one, when you have the square root of a fraction, I'm just going to use the symbol, square root of a fraction. It applies to both the top and the bottom numbers. And the words I'd put on the third one is that a square root and a power of 2, a square, cancel each other out because they're opposites. Okay, that's as far as I want to go today. For homework, and I will put this up in Google Classroom as well, of course, I'd like you to try page 24 to 25, questions 1 to 3, and question 5. Okay, thank you very much, and I'll talk to you tomorrow.